Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to mix up some math and science. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited to introduce our two panelists for tonight, Eric Archer and Curtis Brown. Eric is the Market Strategy Manager for the Worldwide Science and STEM Education Markets for Texas Instruments. He continues to lead the efforts for the development of content-based STEM programs such as STEM Behind Hollywood and STEM Behind Health. Eric, thanks so much for joining us tonight.
Thanks, Mike.
And Curtis is the Market Segment Manager for the Mathematics Education Market at Texas Instruments. He is heading up the development of content-based math programs such as building concepts and activities in the STEM Behind series. Curtis was an AP Statistics and Algebra 2 teacher in Houston and worked as a statistics content specialist at the National Math and Science Initiative. Curtis, thanks so much for being with us tonight.
Happy to be here.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions to Eric or Curtis using the Q&A window on the right side of your screen. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu and choose Audio Broadcast. If that doesn't work, find your name in the participant window, and in that same window there'll be a little phone icon probably in the lower left-hand corner. If you click that phone icon, it will give you information to call in using a mobile phone or landline, and that should solve any potential audio issues that you have moving forward. At this point, Eric is going to discuss our agenda.
Thanks a lot for the introduction, Mike, and I can tell everybody on the phone that Curtis and I are really excited to talk about this webinar. We're going to talk specifically about one of the activities that's part of the STEM Behind Cool Careers series that TI just launched not too long ago. And this is a little different than the other STEM Behind activities that we've created in the past, in that the real purpose on this program was to help students see that math and science are really, if they look, are in just about any career that they go into. And so the careers that are focused in on this particular program are around food science, fashion design, and Curtis is going to walk you through a really cool activity. It's a math activity, but it's got a lot of really cool science in it. Around art and painting and how light works in terms of color mixing. And so it's a pretty fascinating activity. I think you're going to like it. Now, these activities that are part of the STEM Behind Cool Careers work on both TI-84 CE and the TI-Nspire handhelds. So no matter what you have, you can download the files that will work for those handhelds. And we really tried hard to make sure that the files were the same as much as possible for both of those platforms. So even if you have a mixed handheld classroom, which most of you probably don't, but a few of you might, the kids should have a similar experience as they go through each of the activities. So it's pretty cool in that regard. The 84 CE has really made it nice and getting some of this this very visual, very colorful content across, and you'll see some of that tonight. I think Curtis is going to focus in on Nspire, but everything you're seeing on the Nspire works on the 84 CE in much the same way. And then online resources. So Curtis is going to show the website here in a little while. Curtis is going to kind of drive the slides that you see on the webinar, but you'll see what's available. There's a lot of cool videos that are available. John Urschel helped us with this particular program as well in terms of getting the message out that, you know, no matter what you do for a living, there's math and science in those careers. And so this is coming from a NFL football player, so, you know, and a PhD candidate at MIT, so pretty neat guy. And then finally, you have the opportunity to win a registration for 2 people to the 2018 T-Cubed International Conference, and this coming T-Cubed IC is going to be in San Antonio, March 2nd through the 4th. So that's also available for 2 lucky, or for 1 lucky person that can use it for 2 registrations. 2 people on the webinar that can win that are part of this webinar. So good chance of winning right there. All right, Mike, if you want to go to the next slide. Curtis, did you want to talk about a little bit about the expected outcomes?
Sure, I can talk to that a little bit. So tonight we're going to be focusing in on, like Eric said, we're going to be looking at one of these activities from this series, STEM Behind Cool Careers, focused specifically on the math and science in art. And so the beginning of the activity, we're going to look at exploring kind of the properties of light and pigment, looking at the red, green, blue properties of light and kind of how they're additive, and then really the subtractive property, the absorptive property of pigment and the way those 2 interact to help us see the colors that we see when we look at paintings and we look at really the world around us. Secondly, we're going to look at examining ratios themselves and just, you know, some strategies. This gives us a context for looking at strategies for comparing ratios, and gives the students kind of something more interesting than just looking at 2 to 3 and 3 to 4 and trying to compare those 2 outright. We can do that within the context of mixing paints for a particular painting. And then lastly, we're going to look at applying the understanding that students kind of develop through this lesson in scale drawings and in comparing ratios for painting and colors to an actual mural. So we're going to check out some of the stuff there as we go through this lesson. So should be pretty interesting. And I saw, Mike, you just gave me power to share, so I should probably do that. We can get going on this activity.
Hey, Curtis, while you're doing that, I'll just comment real quick. So when these activities were developed, and there are 3 currently, we think we'll add more. In fact, there's a contest that on the website for the opportunity for the winner of the contest to dictate kind of what the next career is going to be, which is pretty cool. But we worked with actual experts in their fields. So we worked with basically for this particular activity, we worked with a couple of guys that run this mural company that Curtis will show you. And then we worked with on the food science. We worked with an ice cream company. It's pretty cool. And then for the fashion design activity, we worked with an actual local fashion design firm here in the Dallas-Fort Worth area to try to understand the math and the science behind those fields. So it's pretty cool stuff. It's based on real-world kinds of careers. It's pretty neat. All right, Curtis.
Yeah, and I pulled up the website here. So September 25th is the final date to submit a photo to have your submission considered for the contest. And so you can go here to genstemcontest.com and check out that content and submit something there, which would be pretty cool and exciting. I'm looking forward to, both Eric and I are looking forward to working with the winner of that contest and helping us develop a new bit of content. So let's jump into this lesson. It's called Math and Art Form. So this lesson was based upon, like Eric said, the guys over at Icon Murals. Incorporated. They're here in Dallas, in the Dallas-Fort Worth area. Chris and Jeff were very excited to work with us and passionate about the math and science that goes into creating the murals that they create. And so we went and looked at some of the material that they've painted over the years here in the Dallas-Fort Worth area and selected a mural, which you guys will get a chance to kind of check out here. And it was really interesting to talk to them just in the math that they went through to take this little tiny drawing that they make, and I say tiny, it was I don't remember what the dimensions are, and we'll see it here in a second, but take that drawing and scale it up to this 12-story building. And just the math and ratios and things that are applied there that students, we do all the time in the middle grades. We talk about those things, but then to see it really happening in real life, and guys who are passionate about art, who, you know, initially weren't overly excited about their math careers, and then when they kind of made the connection here, they were just super excited about the math that they were doing and really interested to check that out and be able to share that with students. And so the introduction of the activity is kind of in a storyline, so we talk to the students via the calculator and via a handout, and just kind of prompt students to follow us through this. So the scenario is that there's been a car fire on one of the murals that these guys have painted, and we're going to go and help them repair that. But before we can do that, we first of all have to talk a little bit about light. We need to talk about how light works and how light works with pigment in order to kind of create the colors that we actually see. And so we base this on a red, green, blue primary colors of light concept and a cyan, magenta, yellow primary colors of pigment. And I know that there's other ways to kind of look at light and look at pigment, but this was kind of the route that we chose. In particular, when we start talking about the primary colors of pigment and we say that cyan, magenta, and yellow are the primary colors, the students, you know, they start raising their hand. Wait a minute, that wasn't what I was told in kindergarten. And well, that's true. We weren't taught about cyan and magenta in kindergarten, but this really is kind of the way things work with the CMY, and so you know, we jumped into kind of hopefully giving students a place to jump off and deal with that. I introduced the idea that light mixes and adds up to what we see as white light, and that paint or pigment, not being an emitter of light, actually has to reflect light for you to be able to see it, and so it's a result of what colors are absorbed and the remaining colors that it actually reflects. And so on the next page in this TNS document, we're navigating to the next page here. We have a Lua strip that shows both the light wheel and a color wheel. So I'm going to have the light wheel animate up here, and you guys can see kind of the overlapping piece of this. And one of the first things we really love having students do is taking time to move the squares around and kind of concentrate on, you know, what are the color combinations that they get to see, what happens when I mix blue and red light together. Well, I get a resulting color that looks like magenta. They spend some time just working through this and playing with this a little bit. Just seeing those two together, and then being able to compare the light wheel with a pigment wheel. You know, we talked about it a little bit at the beginning that the three primary colors of light add up to what we see as white light or natural light. But then if you look over here on the right-hand side, we have the pigment wheel, and the center of that pigment wheel is actually theoretically no light at all, or black. And so that's kind of an initial kind of conversation. Okay, so what's going on here? Why does that work, or why does that happen? So if we take maybe two colors in the pigment wheel and we start talking about, okay, so why is it that when I put cyan and yellow together, why is it that I see green? Because that's a familiar concept for students, right? They've talked about from early on that if they mix blue and they mix yellow, or sorry, blue and yellow, right, or blue and yellow, they make green color. So cyan's not too far of a stretch for that for them. And the reason is that cyan paint reflects both the blue and green light, but it happens to absorb red light. You'll notice that that where the red is there on the cyan, it actually is sucked in. Okay, so it's absorbed red, it reflects blue and green, and when you mix the yellow, well, yellow reflects green and red but absorbs blue, and so when you combine those two things together, the only thing that's actually being reflected from both of those two colors is the green light. And so that's why when we look at cyan and yellow mixed together, that we see that green light being reflected back, and that's what hits our eyes, and that's actually what we visually see when we mix those two pigments together. And so you can kind of have a conversation about the different combinations and the ways that things work together, and students can play with this a little while, and they really get into you know, just seeing those two pieces together. A second thing that's kind of cool, or at least I thought it was cool when I was playing with this and having to do a little bit of research on my own and learn a little bit about light and color and the way that these things work together, was that the primary colors of light, or sorry, the secondary colors of light end up being the primary colors of pigment, and vice versa. That the secondary colors of pigment, or the things that when you mix these primary colors together, what you get back are the primary colors of light, and that's really because of the absorptive properties there in the pigment. And so there's some really interesting things that go on here, and it gives you a platform in a math classroom to, you know, give light, pardon the pun there, to some of the things in science that go on, and I think that this could also be a really nice place in a science classroom to, you know, have a launch pad for your conversations about light and the properties of light and the way that light mixes together. So we wanted to give students just kind of an interactive place to do that.
Yeah, Curtis, I agree. This was this is one of my favorite parts of this activity, and I think it's kind of a mind twister, well, at least for me. You know, knowing about the emission of light versus the absorption of light. And Curtis, I think you did a good job of pointing out that the secondary colors of the pigment wheel are the primary colors of the light wheel, and then the secondary colors of the light wheel are the primary colors of the pigment wheel. You know, they're sort of opposite, and it, you know, it stands to reason that you know, one of these, the light's hitting your eye, and the other one, the light's being absorbed. And so it's you know, it's pretty cool, but it does make you think a little bit. Other places in science you could do something with this are, you know, when you talk about color blindness and, you know, the alleles that are associated with color blindness, it mostly shows up in men because it's a sex-linked trait, and you can talk about, you know, red-green color blindness, and why does that happen? Well, it's kind of the same reason. So if part of your receptors aren't picking up one of the colors, then things are going to look a little different to one individual versus another. There are a lot of places we could explore color in the science curriculum, specifically in physical science, but also, like I said, with color blindness in the life sciences. So pretty cool and very applicable to science here.
Cool. Thanks, Eric. So as we kind of move from this introduction of light and pigment and kind of the comparison, I want to make sure that some of that stuck. And so in the activity, we actually provided a page here that presents the students with several different questions of what color do these two lights make, you know, when we overlap these two together, when we shine and highlight something with red and green, what color should we expect to see being reflected back off of things, or what should we expect to be seen being the illuminating color? And so Students can use the keypad to choose a value 1 through 7 here as their response, or they can actually just click on it using the touchpad. That's one of the features on the Nspire that's kind of a handy. They can actually use the touchpad and click on those spaces. And I think, if I recall right, that this should come back yellow. All right, I got that one right. It's going to take me a little while. Hopefully I get a few of these. But one of the things is kind of cool. So if I pick this one and I say, okay, so magenta, cyan, maybe those come back with red. And one of the nice little features we tried to fit into this was a little bit of feedback, let the students kind of realize, oh yeah, that's right. Magenta and yellow reflect red, so I should maybe see something different. So I can try again or get a different color and make the right response there, or the correct response, and pick that up and get a. So there's a whole bunch of these, and they're randomly generated. So every student should be working on slightly different questions in here. And I want to pull up really. This is actually just popped into my head. I want to pull up really quick and just show you guys that. But this does, in fact, exist on the 84 CE as well. I want to pull this one up and just show that the navigation and all of the things that I've been doing on Nspire are basically the same. So we have just the same text and the same sorts of things being shown on 84 CE. On the page. One of the things that we did not do on this this version of this was that we didn't make the squares movable here, but I can definitely snag these two and have a little bit of the same conversations that I did over there on the Nspire page. So I want to make sure that I hit both platforms here for just a second and just show, hey, if you happen to have a mixed classroom where students have one or both of these platforms, you can still use this or certainly for the folks out there with 84 CE, that this kind of works in the same fashion. So there's only 3 colors in the color mixing quiz here on the CE, but it basically works kind of the same way. I choose a number off of the what did magenta and yellow make? Somebody help me out.
I would need my color wheel.
I don't know. There we go. Got it right. All right. So anyway, it functions kind of the same way. I want to make sure that I get made sure that kind of shows up, and we can see that there. So up to this point, students have kind of been dealing with light and looking at them as just pure, how do these two kind of relate together, paint or light, in a 1-to-1 ratio. In other words, I've got the same amount of both, I'm just sticking them together, and what colors do I make? Now, really, that's probably as far as my artistic ability goes. And so past that point, I really just had to start relying a little bit more on mathematics and the way that things work together. And so we want to jump in and give students kind of a context in which to deal with comparing ratios and being able to discover or think about the ways that two particular mixtures of color actually might come out. So they get to this next page here, page 2.3, and we're talking about talk a little bit about which one of these color mixtures is redder. So as they're following along, they're working through this document, and they get to here. There's a series of questions, a series of things that the teacher can kind of give open classroom discussion kind of concept, and really think about having students working through comparing these two mixtures of paint. And one of the first things that I like to do with this page is to give students just, concentrate on the left-hand side stack of mixes. And so if I just look at this left-hand side set of mixtures, and I use the up and down arrow, and I just look at each one of these possible sets, my question, my students, is, so which one of these, ignoring the one on the right, which one of these in this table is going to be the reddest? And we, let that kind of sink in for a second and get students contemplating, okay, so which one of these is going to be the reddest? How would I even decide that? And they start thinking about it a little bit, and naturally there's going to be at least a few of them that say, well, hey, the 12 to 18 has got to be the reddest one from that bunch because it's got the most red. And hopefully that conversation also includes somebody saying, well, yeah, but it's got the most red, but it's also got the most blue. And eventually, hopefully, somebody makes notice that, these are increasing at the exact same rate, right? We're adding two cans of red and 3 cans of blue every time that we cycle through this. And so students kind of get, oh, wait a minute, so these are all equivalent ratios, and we talk a little bit about equivalent ratios and what does that mean, and so how does that relate? Okay, so all of those are going to be the same amount of redness or the same hue of redness if you want to go that direction. So what about the other side? So are these all the same? Students kind of, yeah, they're all the same. Okay, so let's go back to our original question then. Which one of these is in fact the reddest? How do we compare these two, the left and the right, and what are some strategies that you guys can kind of come up with for figuring out a way to decide which one of these is reddest or would have the most red hue? And believe it or not, there's a lot of conversation that happens here that's really, really kind of interesting. For example, one of the modes of thought, and I've even seen this, I've done this with students and I've shared it with some teachers and we've had some conversations, is really kind of interesting. They say, okay, well, we're really good at 0 pairs or things that kind of work like 0 pairs. So I imagine that 1 can of red and 1 can of blue makes the same color of purple, or the same kind of purple color, right? So these two would be the same color, these two would be the same. So all of that is the same color, right? And then if I look down this side, I've got, 5 sets of this, what amounts to like a 0 pair kind of conversation or a thought process. And so some students will even go so far as to say, well, hey, I really just got 1 can of blue paint left over in both cases, so hey, these really still are the same color. They've got the same hue or the same amount of redness, which might sound reasonable until we start kind of thinking about what does that really mean. Well, that's one way of looking at this, and we can talk about, well, gosh, that 1 can that's left over, what ratio of the total amount of paint is that 1 can? And get them thinking in terms of kind of this, well, that 1 can is now, 1/5 of the total amount, and this 1 can is like 1/10 or 11th of the total amount. So wait a minute, that doesn't work. This one might be a little bit, and that's still kind of a hard place for them to go. So that's one place the students kind of get off in this direction. I try to steer them toward looking at the amounts of red. The amounts of red and the amounts of blue in this, and they could really set this up so that they have maybe say the same amount of blue cans, and then it becomes a pretty obvious response. Hey, if I've got the same amount of blue, this one has more red than that one. Or to kind of reverse that thought, well, what if I have the same amount of red cans? How much blue does that compare to? So I've got more red on the right-hand side, the same amount of red to blue. The same amount of red, but less blue on the right-hand side one. So the red one must be the more red color. And so this really gives us kind of lots of different strategies or ways that we can kind of attack this problem of which one of these is redder. And you can spend days actually sitting here on this one page kind of talking about the different ways that students can work on this. Now, one advantage of the TI-Nspire file versus the TI-84 plus CE file, I don't know if you guys have noticed a couple of times here, I've actually clicked inside of that cell. I can actually change the ratios so students can play with the different ratios and look at lots of different kinds of problems. So a teacher could really spend some time here on this page giving different iterations and times for students to spend comparing ratios. But the 84 CE file is fixed into this one specific setup that we had at the very beginning here, but on the Nspire file you could take this and play with it a little bit. But anyway, a nice conversation about and nice thing for students to kind of try to get familiar with how do ratios work and how do they affect color, the color of paint that's mixed, and so there's still the application piece happening, but we also have that math piece happening. We're really going to be able to compare ratios and talk about the value of a ratio and how does that work and why do these things change the way that they do. So you get to look at it from many different ways. Once again, in the same theme as many of the STEM Behind series, we kind of present a context or a topic or a thought process, do a little bit of work, and now we've got some questions that students can do some interaction with. So again, we can choose which one of these is bluer, mixture 1 or mixture 2, and I'll have to think about that just a second. Which mixture is bluer? I'm going to go that mixture 1 is bluer. Yes, got that right. Believe it or not, that was totally on the spot, totally unprepared. That was had to do a little bit of ratios work on my own. But students get to click through this and answer a ton. And you'll notice in the upper left-hand corner there, I've got a score that's going, hey, look at that, I'm doing really good. Maybe if I just stick with the right-hand side, I'll get a whole bunch of them. But you can see that this is totally randomly generated. Students can kind of have competition. They can look back and forth and work together, talk about their strategies for using this particular page. All right, so we've kind of talked a little bit about color and light. And we talked a little bit about mixing of colors and the way that ratios work in paint and the way that we kind of decide colors and maybe mix paints. One of the things that I thought was the most fascinating thing for this activity, the guys, when they, Chris and Jeff, when they get up there to this big mural that they've got painted on the side of a building, they actually have literally taken the drawing that they had at the studio, they bring that with them, and they've literally numbered the drawing and the little spaces where they're going to put the colors in on that drawing at the studio. And then they've got all of the paint mixes that they've made. So they've mixed all these paints prior to going out to paint on the mural. And they literally are looking at their little drawing on the rendering that they call it on the left-hand side there in their hand, and they look, okay, so this little section right here, this section is color 32. And I look for can 32 and I dip my paintbrush in there and I color that section that I've got right there in front of me is colored 32. Because one of the things that I think sometimes, I know for me, not being an artist, that kind of gets lost is when you have, and I'll go ahead and do a spoiler alert here. When you have a drawing that's, say, 30 inches wide and 24 inches tall, that you're trying to scale up to a 12-story parking garage. I don't know if you guys can see that very well, but this is John Urschel, our spokesperson here. He's about 6'4", I think, and NFL football player. So you can kind of imagine, pretty big guy. There's some cars here in the back.
He's very large. very large person.
He's a big dude. I've stood next to him and had a picture taken, and I don't feel small very often, but he can make me feel small. But anyway, it's really, I mean, it's amazing that they're up there on these little walkways that they've put up there up against this building, and up close you don't have any perspective on what it is that you're actually drawing. And these guys literally just make a grid on the wall and associate the sections of that grid with the sections on their rendering, and then they've got these paint by numbers sort of concept going on here. And for me, that was just fascinating, seeing that happen. And I think that's really something that students tie into too, because you know, it's one thing to think, well, gosh, they just get up there and freehand that whole thing. Well, no, that's not actually what happens. Really, they've got this thing pre-planned. They scaled this thing, which is, you know, really cool. And I saw Mark there, yeah, the scale problems, taking something that can be kind of mundane and putting in a real life context. And that's exactly where we're headed with this problem now. Yeah, give it a purpose and a reason. I mean, these guys get passionate about. And that was one of the things that was so cool, that Chris was just so excited to share with the world, hey, we really do a whole bunch of math to make these pictures happen. And so the next thing that we're going to do is talk about scale. And so we put the students in that same, you know, kind of problem, give them a little bit of practice with some similar triangles, get them thinking about the way that the sides work together, and we ask several questions about that. Just to get them some practice with what does scale factor tell you? How does that work? Suppose you had a scale factor of 12 applied to the 3, 4, 5 right triangle. What are the new lengths? And we give them just a little bit of practice, some piece of this. And one of the things that I want to kind of share here, because where this really goes and where this becomes really kind of effective is when students go beyond just what does the scale factor mean, but try to take it back to, let's suppose for a moment that the units of length on the magenta triangle are in feet, and the units of length on the white triangle are in inches. Let's think about that for a second. Ask the students then to write a ratio, including the units, that shows the relationship between inches on the white triangle and feet on the magenta triangle, and get them thinking about what does that actually represent. So 5 inches is 10 feet. So that means that 1 inch is 2 feet. So now we kind of get this context for, okay, so I'm using this white triangle to kind of work my way towards what is that magenta triangle there on the right-hand side, and what the units are there. And then we navigate from this page, and we start moving into the actual application of the mural. And the guys at Icon Mural were very gracious enough to allow us to have a car fire in front of, no, I'm kidding. We put that car fire smoke damage on this image for this calculator application. This is not a real thing that happened. Would be kind of interesting if it was, but no, this was an imaginary car fire that happened here. But we put it there so that students would have a space to kind of now apply all of the work that they've just been doing throughout this lesson. So now the questions become, okay, so we got this little section here on this big, beautiful mural, and they were gracious enough to allow us to deface their mural for a second. And so we give the dimensions of this picture. So now I can give you, and these really are the real dimensions that they used. So it is 120 feet tall. It's a 12-story parking garage. It's 160 feet wide. And they choose to use a 22.5 inch by 30-inch sheet of paper. And it fills the entire paper, that image does. So at that scale, how many inches in the drawing represent 1 foot in the parking garage? and I'll go ahead and do the math really fast for us. I think it comes out to be 3/16 of an inch, I hope. Let's find out. Yes. On that 3/16 inch scale, that means 1 foot in the parking garage. So the artist used these 4x4 squares. So on the actual mural, on the actual wall itself, they painted a grid that was kind of these 4-foot squares. All the way down, they started at the top, and they actually drop a plumb line. So they get up there in their walkway, and they drop a plumb line down with a chalk line. They hold that thing, and they pop a chalk line on there, and they get themselves a grid to work with. It's just fascinating that these guys just do so much mathematics to make these pictures happen. It's just so cool. So they use that for their reference on the drawing itself. So 4x4 is what we're going to go with there. So based on that information, if we number the parking garage on the lower left to be 0, 0, and we work our way in the first quadrant basically through this, what is the section defined by 3/2 of an inch to 21 1/4 inches, or sorry, 2 1/4 inches, and then taking it from 0 to 9 inches. Mike, I think they actually do have a time-lapse video of this particular one. I don't have it pulled up, but Eric may be able to Google that, and we can give him rights to share that, maybe. So let's go through this. Huh?
Oh, I was just saying I'm on it. I'm working on it.
You're on it? All right, fantastic. All right, so let's put in some values here. I believe that at the ratio that we have, it comes out to be that the left marker is 8 feet in, and the right marker is 28 feet in. So we have a 20-foot section, 20-foot wide section that we're doing, and then it goes from 0 to 48. Gosh, I hope. I don't remember the answers, guys. So, okay, good. So your boundary is correct. We give them a little bit of feedback. If I had put in something wrong, give me some feedback and ask me if I want to change that or update my response. And then the question now goes back to using that comparing ratios or that color mixing stuff. So if the original ratio of yellow to red was 5 to 3, and we need 64 ounces of orange paint. So this is kind of an interesting question. We need a total of 64 ounces of this orange color. How much red and how much yellow do we need at a ratio of 5 to 3? Conveniently chosen numbers here. Hopefully it comes out nicely. So we should need about 40 ounces of yellow paint, and I guess that leaves us 24 ounces of red paint. And believe it or not, we get this cool little orange background now that we've kind of set a base for this piece to be colored. And then if I press enter to continue, hey, look at that, the mural was fixed. We allowed them to get the mural taken care of and popped up and repaired. And students really have gotten into pay no attention to that man behind the curtain, that's for sure. A little bit of magic happened, and look at that. But students really kind of get into the idea that, hey, you know, this math that we're learning in math class, all of these ratios and this proportional reasoning stuff, it's not just for the guys who are going out and going to be double E's and work at Texas Instruments, or they're going to be doctors and nurses and prescribing. No, this is really for all these different careers. And even in the arts, we're really interested, we need to be at least really interested in the mathematics and the science that we're learning now in the middle grades, because it's going to apply to what we're going to be doing later on in our lives. And I think that was one of the big driving forces behind us looking at doing this STEM Behind Cool Careers set of materials, was that we wanted to really engage students who might not necessarily be the first student engaged in a math class or a STEM class right away. We wanted to give those guys and you teachers a place to go to try to engage those students as well. So I'm going to pull up the website really quick and just show you kind of a few highlights from what's here. You'll notice we do have a Lightbox kind of a play video there for you to introduce the activity with. It goes through, John Urschel actually introduces, and he went out to the studio and kind of checked out Icon Studios, and the guys really, they got into it and actually invited John to do a little bit of painting in the studio, which is pretty fun to see in that video and kind of the interaction there. But somewhere down on the page, about halfway down, we have the download section, so you can download the teacher and student files, all of the files, the calculator files ready to go for both platforms, the 84 Plus CE and for the TI-Nspire CX as well. And you get a little picture of Chris and Jeff and their studio and a little bit of the background behind that. And then we also have, and I told Eric earlier that I really want to make sure that we highlight a little bit of some of the other activities. I know we walked through the math activity, which was really the purpose of this particular one, but I also wanted to just quickly pull up the website here. So the fashion activity, when we went to work with Mario, pictured here in this picture there, when we went into his studio, it was really fun to kind of talk to him a little bit about, okay, so what is it, the math that you're using here? And we really we focused a lot on the geometry that it takes to create some of the designs that he comes up with. And this particular activity goes straight to kind of Fashion 101 and looking at the creation of a circle skirt. And so that we really dive into the mathematics behind a circle and really where does it come from, and we use Pythagorean theorem as a place to develop the equation of a circle and kind of extrapolate that out to circles and apply that in the creation of these circle skirts. Eric, you were trying to talk there for a second.
No, I was listening. You're good. Keep going.
Okay. So anyway, I thought that was really kind of a fun way to get into that, and I'll pull this up here. I've got it here on the Nspire here pulled up, and I wanted to just show you a little bit of the demo that we have in here on this particular activity, which is really fun. So students pull this dot around. They use the arrow keys and navigate this dot around the page and make note of how x squared and y squared are changing together, and they think a little bit about it. That would just kind of lead them carefully towards this concept, and then we ask them to use the show command, and we go, gosh, there's something that we know about right triangles, and eventually students get a little bit of they jump on this bandwagon, and they note, hey, wait a minute, 1.48 plus 2.52, gosh, that adds up to it looks like it must be added up to right up to 4, and they see, gosh, if I continue moving this around, and then somebody in the room goes, hey, look, the radius is 2. Gosh, the radius is 2. So that length there is 2, a squared, b squared, c, hey, and we really get this cool definition. So, hey, in fact, somebody mentioned there, I saw the unit circle come up, so let's change it. Let's put this on the unit circle and see if this applies on the unit. I'll pay you later, Rabib. So let's play on the unit circle. And then what about a radius of 4? And does this still apply at a radius of 4? And we play in that same case. And so then we'll take that mathematics and go and apply it to go and apply it to the context of creating a circle skirt. And not to leave the science folks out, but I think this really also has some cool mathematics stuff to it, but there's also an ice cream cool science. And before I show you the TI-Nspire page on that, I want to jump over to the website just so you can see the ice cream cool science. We went up to this group in Beth Marie's old-fashioned ice cream parlor in downtown Denton, Texas. Is a really cool place to go and check out their ice cream. And yes, we did get to sample a little bit of it. It was fabulous. Same sort of thing. You get the download here, a little bit of a video telling kind of the story and the way that this this lesson was developed and worked. And I apologize that you haven't had dinner yet. Don't want to make you hungry for ice cream, but that's okay. The ice cream cool science activity, really, Eric, I think you can speak to this, but I also have some math stuff I want to talk about it. But go ahead and I'll walk through just, briefly. I can show a couple things if you want.
Sure.
Then I'll talk math to it.
This activity was meant for like a middle school science classroom to get students involved in states of matter. It's kind of an abstract concept in a way because students can't see what's going on at the molecular level. They can see ice, they can see water, they can even see steam when you boil water. But this activity was just using ice cream as a fun and a nice way to get them thinking about ice cream is actually a combination of all three states of matter, which you wouldn't think because it's ice cream. It comes out of the freezer. You would think it's all solid, but it's not. There are ice crystals that are solid. The sugar and the flavoring makes it kind of a liquid syrup that's mixed in with the ice. And then what a lot of folks don't know is that about 40% of the volume of most ice cream is actually nothing but air. So there's a gas there. So ice cream's a combination of all three states of matter, which is something a little mind, twisting for kids to think about, actually adults, me too. And so I think that's really neat. So yeah, Curtis just kind of flipped through some of these. There's the storefront for Beth Marie's, and then we talk a little bit about what is a solid, gas, and a liquid on that page. And then I think we get into just a sort of a diagram of state changes, and each of those arrows represents some kind of phase change, so freezing, melting, vaporization, or an example of that would be boiling, of course. And we go through that. Keep going, Curtis, just for time's sake. We get into a fun little, this is just a slide animation, but we talk about the process of ice cream. It comes from milk, of course, and the pasteurization of milk and how the temperature changes there. So there's this little thermometer on the side to give the kids an idea that there's a temperature roller coaster in the process of making ice cream. I mean, the temperature is going, it's room temperature or it's cal temperature to start with, and then it goes up, and then it goes back down, and then we make ice cream out of it, and it's hardened at a really cold temperature, and then we warm the ice cream up to -9 degrees C. Which is another weird thing to say. You warm it to -9 degrees C, okay, for dipping. And then finally, I think the next slide shows that shows a kid enjoying the ice cream. The ice cream's in his mouth at 37 degrees C. So it takes them through this idea that temperature and states of matter are proportional. They're related. They go hand in hand. And then Curtis, I can't remember what page it is, but there's some more molecular kinds of representations a little bit later in the activity. But did you want to talk about a little math? Is that?
Yeah, I wanted to. So there was a method to my madness in putting you on the spot for this because I really liked the fact we had John Urschel go out and do he actually went to a school in Baltimore and used this activity in a math classroom because he was able to, we were able to talk a little bit about that temperature. You mentioned the temperature roller coaster, and that's really kind of a cool thing when students get to relate rates of change to the creation of ice cream. And so we have the graph of the temperature of the ice cream throughout this entire ice cream making process, and the way students were able to write equations and talk about relating rates of change to the actual changes of states of matter in the ice cream that they were about to go and consume. So it was really kind of a nice, a mixture of math and science. Man, the puns are getting deep in here tonight. The students really got into it, and that was really a neat experience to see students take a science experiment or a science thing that was happening and relate it to a mathematical experience as well. So that was pretty neat. So I'll pull up those graphs there, the molecular structure stuff that you were talking about, Eric.
Yeah, and as Curtis is flipping through the slides, you'll see you saw a picture of a gentleman. His name's Hattie. Hattie Morales, and he actually makes all of the ice cream that Beth Marie's makes. The guy's really busy because they're making ice cream that goes into a lot of the grocery store chains around here, which is pretty cool. But the poor guy, he's running around like crazy making all this ice cream. But he's a pro at it. It's what he does. It was pretty cool talking to the people that actually do these careers and having conversations with them and watching what they do. And we tried to capture as much of that in these activities, as practical. But I think it'll help the kids get a better idea of, hey, what does it mean to make ice cream? What kind of career is there in food science? Is that something I'm interested in? In addition, above and beyond the math and the science that we're talking about, these kids are going to have jobs eventually and careers. And so I think these activities do a really nice job of trying to reveal some possibilities for them, for the future. And yeah, thanks, Curtis. So this is just a simple molecular representation to show that when you add heat to a system, the molecules become excited. The space between those molecules becomes excited. And so that's the reason for, solids are very organized and very close together. Liquids a little less so. And of course, gas, the molecules are very excited, so they're moving away from one another in a pretty excited state. So, and then the graph, of course, gives you a nice visual representation of what's happening. Parts of this activity can be used in a chemistry classroom as well. For the molecular representations, you can get into heat diffusion and talk about those concepts with it, in addition to just the states of matter. So, Curtis, I think we're running out of time here. We got about 4 minutes, and I think Mike probably has some things to talk about.
I think so too. So, Mike, I think we can pretty well wrap this up. I just want to say one more time. I know we highlighted a lot of TI-Nspire CX on this session tonight, but the vast majority of all of those different things that we showed are things that can be also done with the TI-84 plus CE. And so analogous files or the same side can be worked side by side.
Thanks so much, Curtis and Eric.
Yeah.
And go ahead. Sorry, Eric.
No, sorry. I was just laughing at Mark's comment about you had me at Cal to Cone. Sorry, I didn't mean to laugh out loud.
All of the files that Eric and Curtis showed tonight, we're going to be providing you in a few minutes. So feel free to visit our website to get those, or just hang tight next couple minutes here.
All right. I'm going to pass the ball back over to you, Mike.
Thanks. So as Eric mentioned earlier, we are excited that the T-Cubed International Conference is coming to San Antonio in early March this coming year. It's a great place to get in touch with Eric and Curtis and learn a little more about STEM too, and some of these activities that are being used. So please feel free to join us at the T-Cubed International Conference. Also, Eric mentioned that tonight we're giving away to one lucky winner a T-Cubed International Conference registration, and tonight's lucky winner is Gabrielle Wan. So Gabrielle, congratulations. We'll be in touch over email in the next couple of days to give you some more information, but we hope to see Gabrielle as well as everyone else at the T-Cubed International Conference. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents that were used tonight. in case you missed those 2 links or they're not working for whatever reason, feel free just to wait in your email. In a couple of days, you'll automatically get a follow-up email, and in that follow-up email will be a link to the recording, a link to the documents, as well as a link to the certificate of attendance. And if you're watching this on demand, go ahead and copy that link down to your favorite browser to receive your certificate. Thanks so much, Curtis and Eric, for everything you shared tonight. As I think Eric or Curtis, one of you mentioned that we had lots of puns going on in the chat window, so it was a fun night, but hopefully there was some learning too. So thanks so much for everything you shared, and we hope to see everyone back online real soon. Have a great night.
Thank you.
Thank you.